Hello and welcome to our series of mathematics lesson. We continue to cover the topic on indices and surds. Today we are going to cover two aspects in surds, and that is the indices law extended and then we shall also cover the aspect of negative indices. These are the two concepts which are under the broader topic on numbers and algebra, that is the indices and surds. So we're going to cover the first aspect, which is the index loss, and it is an extension or a build-up of what we had already covered in our previous lesson. Then we have got the negative indices, which we shall make an introduction and be able to discuss about them. During our last lesson, we were able to look at the laws of indices, and we were able to look at 4 of them and how they can be applied. In this case, we said that whenever you have similar or same bases raised to a given power and they are being multiplied, then there's a law used in them. If you have a raised to 5 multiplied by a raised to 4, then you can be able to see that the bases are the same, and therefore what you need to do is that you need to add the powers. Let me call this one m and this one n. So if we are multiplying indices with the same bases, or what we are calling the factors, then we add the powers, and this shall give us a raised to m plus n. Law number 2 is on division of indices that have got the same bases or factors. If we have a raised to m divided by a raised to n, then the law changes now to be the case that we shall now be adding the powers together, and this shall give us a raised to m. We get the difference of the powers, m minus n. The third law, which we were able to see, was in the case of whenever you have a power of another power. Like for example, we have a raised to power m, and again we raise the whole of this to power n. What is supposed to happen? So in this case, whatever we are going to have will multiply these two powers together, and therefore the result will be a raised to mn, the product of the two. Then lastly, we're able to look at the case whenever we have a zero index, where we say that any number that has been raised to 0, where 0 is its power or its index, then that number automatically goes to 1. So that, for example, if you have a raised to 0, where a can be any integer, negative, positive, 0, going up to maximum, positive maximum and negative maximum, minimum, then this result to 1. And we said whenever you have any number raised to 0, that number automatically goes to 1. So today we are going to look at how we can be able to extend our knowledge on those particular laws. Now there are cases where we have a combination of an operation that requires us to use or to apply the different laws, be it division, be it multiplicative law, or the one that involves a zero index or a power of a power. Like for example, if you are given a case of 2x, the whole of it is raised to 2. This is not a simpler scenario which we have been looking at. Or you are given 4 all over x, the whole of it raised to 2. Then you'll discover that there's another complex operation that you now bring it in. Now in this case, or in the first case, whatever we have inside the bracket, they must be raised to the given power. So that means we treat each individual independently in this particular context, so that the power affects everything inside the bracket. So that in this case, we shall now have 2 being affected by the power, and also x being affected by the power. And then you finally evaluate where 2 squared will give you 4 and x squared will give you x, finally giving you 4x squared. In this other case, the same is going to be applied. Inside the brackets, we have 4 over x. For us to be able to evaluate this, we should be able to understand that this power is going to affect everything inside the brackets, and therefore 4 will be affected by the power of 2, also x will be affected by that power of 2. So it is independent. Whether we are multiplying or we are dividing, the power outside the brackets affect every content of that particular bracket. So this will give us 16 all over x squared. So generally, if you have a multiplied by b and the whole of it has been raised to m, this means that this is going to be ab raised to the power of m when you now eliminate that multiplicative sign. And then this will mean that everything inside the bracket is being affected by the power, and hence the result should be a raised to m multiplied by b raised to m. That is, when multiplying, two or more numbers raised to the power, and you are raising it to the power of m, as we were able to see, then we need to raise each number inside the brackets by the said power or the power in question. So like in this case, you can be able to see we are having these two pronumerals being divided by a multiplication sign. So in this case, whenever we are multiplying, there can be 2 or more. Then that follows that that power in which those contents of the brackets have been raised to, we should affect, or we need to raise each number inside the brackets by the said power. And that's why we raised a by the said power, which is m. We raised b by the said power, which is m. Let's look at a case when we have division. And now in this case, we have a over b, again the whole of it raised to the power of m. Then, because the power is affecting everything inside the bracket, then we are going to filter in this power m, and therefore we are going to have a raised to that power divided by, also b is inside the bracket, therefore it's going to be affected, and we shall have b raised to the power of m. And this should be the case whenever b is not equal to 0. So b, or the denominator, should never be equal to 0, because in mathematics there's a rule that says you should never divide by a 0. And this says that whenever, or when dividing two numbers, and they can be numbers or pronumerals, raised to a power, then we need to multiply then we need to raise each number by the power in question. And this is what has taken place. A has been raised to m, b has also been raised to m. We are now going to consider and look at a number of examples on how we can be able to solve or to use the extension of the two laws in solving different problems. Example 1. Expand each of the following. Number 1, we have 5b, the whole of this raised to 3. Number b, we have negative 2x cubed, y, the whole of it raised to the power of 4. And number c, we have 4 into c squared d cubed, the whole of it raised to the power of 5. So these are cases where we have at times powers of powers, but the main rule that is connecting these three examples is that we are using multiplication. And under the extension of the laws, these tell us that we are going to use the first extension laws, which basically deals with multiplication. So we had said that whenever you have 5b raised to the power of 3, that means everything inside that particular bracket have been raised to the power of 3. And therefore, each independently will be raised to the power of 3. That means we're going to have 5 cubed multiplied by b cubed. That happens after filtering in the said power. Now this will give us, when you take 5 cubed or 5 3 times, we are going to get 125. We are multiplying it by b cubed, and this will result to 125 b cubed as the result. So one thing is clear, the power is filtered inside, or it affects everything inside the bracket. Number 2, we again consider this particular set. So first we are having this negative sign inside the brackets, or finding it in, itself inside the brackets. We had said that whenever you raise a number to an even power, that number automatically becomes positive. So this tells us that everything inside this bracket being raised to the power of 4, which is an even number, the result of these brackets are going to be positive. Now we need to filter in the power, which is 4. But when you reach here, x raised to 3, then you'll recall that this is a power of a power. And what happens to a power of a power? We multiply the powers together. So in this case, we're going to have 2 raised to the power of 4 multiplied by x raised to 3, again raised to 4. So we multiply the powers, which will give us 12, then y raised to the power of 4. Now when you get 2 to the power of 4, you'll get 32. You'll get 16. You'll get 16. So this will give us 16. X raised to 12, y raised to the power of 4. So everything inside the bracket have been affected by the said power, which is 4. And we are clearly saying here that the negative sign is going to change to be positive because we are raising the whole of this number to a positive power. But let's say this was an odd power, let's say 5, then that means our result will obviously be negative, because a negative number raised to an odd power, that number remains to be negative. Or you should have taken the whole of this as negative 2 raised to the power of 4, which will have still given you positive 16. Now we have this third scenario. Here we notice a few changes that have been done. Where is 4? Is it inside the said bracket or is it outside the said bracket? You can be able to discover that 4 is outside the bracket, and therefore it's not going to be affected by the power. This 5 will only affect these 2 pronumerals which are inside the brackets, and this will tell us that during formation of our result, 4 will remain as that. Then we raise c squared to the power of 5, and again you recall that this is raising a power to another power. When you raise a power to another power, we are going to multiply the powers for us to have the result. So this will give us c raised to 2 multiplied by 5, which is 10, multiplied by d cubed, that will be 3 multiplied by 5, which will give us 15. Then we finally degenerate the result, which shall be 4, c raised to 10, d raised to the power of 15. So notice how those laws are being extended and are being played about. So these 3 cases are the cases when we have multiplication. Let's look at a case where we have division. Simplify the following. Number 1, we have 6 over b, the whole of it raised to the power of 3, and number b, negative 2a squared over 3b c cubed, the whole of it raised to the power of 4. So let us do this 2 first on how we can be able to divide through. Now we had said whenever we have division, we are still going to filter the power inside the 2. That is both the numerator and the denominator. So in this case, we are going to have 6 raised to the power of 3 divided by, again b will be affected by that power, we shall have b cubed. Now when you get 6 cubed, you'll get 216, all of this divided by b cubed. Later on, as we shall be learning how to write negative indices, we shall be able to know how can we be able to write this expression as a one term, that is as one expression instead of having it being divided by a given number. So we have said we filter in the powers, that is we raise each content inside the bracket to the power of 3. Now considering this second example, whatever we have also done there is going to be repeated. We are going to filter the power of 4 inside the contents of what we have here. Now, this -2 being raised to power 4, the whole of it being raised to the power of 4, a has been raised to 2, but we're again raising it to the power of 4. That means it's a power of another power. Hence, we are going to multiply the powers, which will give us 2 by 4 is 8. Divided by, the 4 is going to again affect the denominator, where we shall have 3 raised to the power of 4 multiplied by b raised to the power of 4 multiplied by c cubed, again raised to the power of 4. So it's a power of another power, hence we multiply the powers. 3 by 4 will give us 12. When doing simplification, -2 raised to the power of 4 will give us 16, positive 16, so that will be 16 a raised to 8, over 3 raised to the power of 4 will give us 81, b raised to 4, c raised to 12. So again, we can be able to see how the powers are playing out very nicely. So always recall that whenever you raise a number, a negative number, by a power which is even, the overall result is going to be a positive number. Part C, part C of the same, we have x squared, y cubed over c. The whole of it has been raised to the power of 3, and we are multiplying the whole of this by xc over y, and the whole of it being raised to the power of 4. So in this case, we are going to treat each bracket independently, and everything inside each bracket is going to be affected by the power in question. So in this case, whenever we apply that power, these are powers of another power. So we shall have x raised to 2 by 3, which is 6, y raised to 3 by 3, which is 9, all over c raised to that power. Then the whole of it being multiplied by, in this other bracket, we are having all of them being raised to the power of 4. So this will be x raised to 4 multiplied by c raised to 4 all over y, again raised to the power of 4. So when we make the simplification, this is going to be x raised to 6, y raised to 9 over c cubed times x raised to 4, c raised to 4 all over y raised to 4. Now you discover that there are only 3 pronumerals in this case. We have x, we have y, and we have c. So let's now combine the division and the multiplication laws of indices to be able to solve this. And we are beginning with x. So we have x raised to 6 multiplied by x raised to 4. That means we are going to add the powers. So 6 plus 4. Then we have got y which is 9 or raised to 9, but divided by y raised to 4. That means we subtract the 4, or we subtract the powers. And then finally we have got c, and for c we have c raised to 4 divided by c cubed. That means again we subtract the powers. So this will give us x raised to 10 multiplied by y raised to 5 multiplied by c raised to 1, which when simplified shall be x raised to 10, y raised to 5, then c. So the whole, we have been able to reduce it to a single term. The third example, we are told the rule. Let me get some more space. We are told that the rule for the number of seeds germinating in a glass house over 2-week period over a 2-week period is given by n is equals to a half of t, the whole of it raised to the power of 3, where n is the number of seeds and t is time in days. Question number 1. Find the number of germinating seeds after 1 we have 4 days, and 2 we have 10 days. So let's first deal with this first part of the question that requires us to find the number of germinating seeds after 4 days. Now you have been told that the number of these germinating seeds is growing following this particular rule. That is, the number of the seeds is equals to a half of the time raised to the power of 3. You will recall that in this case we are going to look or use the extension of the laws of powers, especially that deals with the division. And you recall we had said that whenever we have either multiplication or division of 2 or more numbers or pronumerals, then raised to a given number, then each number independently is going to be raised to that particular said power. Now, we have said that the rule is n is equals to t over 2 raised to the power of 3. Now you have been told that t is 4, where t, we know, insinuates the number of days or time in terms of days. So this will tell us that the number n of the seedlings will be equal to, where there is t we replace with 4 all over 2, the whole of it raised to the power of 3. Now from there are 2 ways which you can choose to go. Number 1 is to first raise each of them to the power of 3, or because 4 is a factor of 2, we can first divide through by 2 for us to have one term which we are going to raise it by 3. But going from what you have been learning, it means we must filter in the power of 3 to both the denominator and the numerator. So this shall be 4 cubed all over 2 cubed. When you find the cube of 4 is 64, the cube of 2 is 8. 64 divided by 8 will give us 8. So this tells us that during the 4th day, 8 seedlings will have germinated. Alternatively, you could have divided 4 by 2, which will have given you 2. 2 raised to 3 will still give you the expected answer, which is 8. Number 2, we have the number of days increased to 10. For us to be able to get the number of the seedlings that will have germinated during the 10th or after the 10th day, then we need to replace the value of t with 10. This will be 10 all over 2 raised to the power of 3. Again, you can choose to first divide, then proceed and raise it to the power of 3. Or you can raise each one of them independently to the power of 3, then divide. So let us choose the first method where we first divide. We know that 10 divided by 2 is going to give us 5. 5 raised to the power of 3 is 125. So this will tell you that after the 10th day, we shall be having 125 seedlings germinated, or which will have germinated in that particular glass house. Part B of the question, that was part A, requiring you to find the number n. Part B says, use the powers of fractions to rewrite the rule. Without brackets. And what is our rule? Our rule is for the growth or germinating seedlings. So n is equals to t all over 2, the whole of it raised to 3. So they now want us to rewrite this particular rule now without the brackets. So n will be equal to, we say that everything inside the bracket should be raised to that particular said power, and therefore we're going to raise this t to 3. We also raise this 2 to the power of 3. But for the pronumerals we may not know, but for the denominator, which is a number, 2 raised to 3 is 8, and therefore this said rule can be written as n is equals to t cubed all over 2 raised to the power of 3, which is 8. So we now want to use this particular rule to solve a particular questions in part C. Which says that use your rule in part B to find the number of seeds germinating after of seeds germinating after 1 we have 6 days, 2 4 days, 4 days. Our rule was saying that n in part B, n is equals to t cubed all over 8. So what you need to simply do is to simply replace the pronumeral there with the given number of days. Like in the first case, we are replacing it with 6. In the second case, we replace t with 4. So this shall give us that n will be 6 raised to the power of 3 all over 8. 6 raised to the power of 3 is 216 divided by 8. It will give us 27. So we shall have 27 seedlings during or after the 6th day. For part B, we have n is equals to t cubed again all over 8. The t pronumeral is going to be affected, or we replace it with 4, so that we'll have n to be equal to 4 cubed all over 8. 4 cubed will give you 64 divided by 8. This will give you 8 seedlings. So you can be able to tie it to the first example that we performed, using or by first raising each of them to the power of 3. The final question on this part of this question, part D, we are told find the number of days, required to germinate required to germinate 1, 64 seeds, and 2, 1 seed. So of course our said formula will remain. N is equals to t over 2, the whole of it raised to 3. Or we can use the newly acquired rule, which says that t is equals to t cubed all over 8. Let us use the newly acquired rule that say that the number of seedlings is equals to t cubed all over 8. Now we are interested in getting the number of t. We have n, which is 64. So when we substitute n with 64, we shall get t cubed all over 8. That means we multiply both sides by 8 to eliminate the denominator. And this will give us t cubed to be equal to 8 by 64, which is 512. And therefore, you to get time, that means you are going to get the cube root of your answer, which will give us 8 days. So that means that you need 8 complete days for you to have germinated 64 seeds. What about if you are talking of simply 1 seed? Then again the rule remains, n is equals to t cubed all over 8, but n is 1. So that means that 1, we make the substitution, 1 is equals to t cubed all over 8. For us to eliminate 8, we need to multiply it on both sides. 1 by 8 will give us 8 is equals to t cubed. And this will tell you that for you to get the value of t, you need to get the cube root of both sides, and the cube root of 8 is 2. So that means for you to germinate 1 seed, you require 2 days. For you to germinate 64 seeds, you require 8 good days. Now this brings us to the end of the discussion on this subtopic, that is on the extension of the laws. We now want to look at negative indices. Which is our second subtopic. Now, there are cases, of course, we know that if you have 2 raised to the power of 3, you can be able to fumble around and get the answer as 8. We have also come to know and understand that if you have a number, let's say 2 raised to the power of 0, we'd say that whenever you have any number raised to the power of 0, what happens? The result is 1. We know that. But what about the case where you are given 2 now raised to negative 1? What should you do? Or you are given 2 raised to the power of negative 6. What happens? So these two cases are the one we are referring to as the negative indices. And you can make a very good consideration of a number like a raised to 3 divided by a raised to 5. This will come clearly into your mind that you need to, because it is division, we simply need to subtract the powers, right? Now, when you subtract the powers, this will be 3 less 5. You discover that now the problem comes in. Whenever you subtract a big number from a small number, you'll automatically get a more smaller number, which is a negative number, and this will give us negative 2. Suppose in that particular scenario, you are required to write this number as a positive power. What do you do? That is what we want to learn and what we want to understand. Now, at this juncture, it will be wise for us to learn what is supposed to happen. You have gotten your result as a raised to a negative power. What you simply need to do is that you simply need to write the reciprocal of this number. We all recall what reciprocals or numbers written in their reciprocals are. Like, for example, the reciprocal of a is simply 1 over a. The reciprocal of b, for instance, is simply 1 over b. The reciprocal of 1 over a will simply be a. That is the characters, both in the numerator and the denominator, swap positions. Now, when you do that, this shall be 1 over a. And now when you write the reciprocal of this power, it automatically goes to be positive. So if the question requires you to write your result as positive powers, then you find the reciprocal, that power automatically goes to be positive. And therefore, this also means that if you have 1, or let me use a raised to the power of m, and we find its reciprocal, this shall be 1 over a. Now the power changes sign to be negative, raised to the power of m. And we can be able to say that a raised to the power negative m means, or is equal to the reciprocal to the reciprocal of that same a raised to a positive power m. And these scenarios is always applicable whenever a is not equal to 0, because you know what tricks or how tricky it is to divide a number by a 0. The number will be so big, which we normally term them as infinite numbers. Examples on how we can be able to solve questions that arose from negative indices. So we now want to look at scenarios or examples of questions which pertain or have negative indices. Example 1. Express each of the following. Express each of the following with positive indices only. Of course, the trouble now comes in here. Number 1, we have x raised to the power of 2, and number B, we have a raised to the power of negative m. Now, this, you have worked out your problem or your question, and you now have the result as x raised to the power of negative 2. The trouble should stop, because you simply need to get the reciprocal of this number and the power goes to positive. So this reciprocal of x will be 1 all over x, then the power automatically goes to positive 2. Just as simple as that. We have a raised to the power of m. Again, there's not much trouble here. What you simply need to do is to find the reciprocal of a, which will be 1 over a, and of course the power automatically goes to positive. So that is what is expected of you whenever you have negative indices. You simply get the reciprocal of the said number or pronumeral, and then the power of that number or the pronumeral will automatically go to positive. Note that now this positive or power of 2 is only affecting the denominator. It does not affect the numerator. Example 2. Example 2, we are told express each of the following. Express each of the following using positive indices only. Number 1, we have 1 over c raised to negative 2. Number B, we have x raised to negative 3 divided by y raised to negative 5. Then finally C, we have got 5 divided by x cubed y raised to negative 4. So in these particular cases, we are going to apply what we learned, the second thing, item on negative indices, that if you have 1 over a raised to negative m, for instance, then the reciprocal of this is a raised to a positive power m. So we're going to base our understanding or our undertaking of these three examples on this. So the first case, we have 1 over c raised to the power of negative 2. Now we are saying that the denominator is and the numerators are going to swap places, and when they swap places, their powers change to positive. So like in this case, the reciprocal of a c, 1 over c, will be c, then raised to the power of 2 all over 1, which will simply be c raised to positive 2. Now part B, we have x raised to negative 3. We have over y raised to negative 5. So again, these two are going to swap places when we are looking for their reciprocals. And this will tell us that y will go up, x will go down. We shall have them like that. Then their powers automatically changes to positive. So it was raised to negative 5, so it becomes positive 5. It was raised to negative 3, it becomes positive 3. Just as simple as that. Get the reciprocal of those two numbers, then the powers automatically goes to positive. Now number C, we have 5 over x cubed, y raised to the power of 4. So the only interesting part for us is y raised to negative 4. That means we need to get the reciprocal of 1 over y raised to negative 4. And this will, 5 will remain. Then y will come to the numerator, and it will now change the power to positive 4 all over x raised to positive 3. So all of them should be left at that, because if you say that you now want to bring x up, then it's going to be raised to negative 3, which will be contrary to the question that requires you to leave your answers in positive indices only. Example 3. We are told express the following. Express the following using positive powers. Using positive powers, then evaluate without using a calculator. Without using a calculator. Number 1, we have 3 raised to negative 4. Number B, we have negative 5 over 3 raised to negative 2. Then number C, we have 2/3, the whole of it raised to negative 4. So this question has got 2 parts. The first part is to rewrite these particular problems in positive powers. Then we now move in and evaluate without using a calculator. So the first one, 3 raised to the power of negative 4, we simply get the reciprocal of 3, which is going to be 1 over 3. And now the power shifts or changes to be raised to power 4. That is the first part. We have written this problem as a positive power. 3 raised to the power of 4, we do understand is 81. Now that is evaluation. So this will be 1 all over 84. I mean 81. So 1 over 81 is the result of 3 raised to the power of -4. Part B, recall we need to rewrite this again as a positive power, but the negative power is in the denominator. So when you bring this back to the numerator, then the power will change to be positive. So the negative does not affect anything and it remains as that. So we shall have -5 multiplied by the reciprocal of a third, which will be 3, and the power changes to be raised to power 2. So this will give us -5 multiplied by 3 raised to the power of 2 is 9. And when you multiply -5 by 9, you will get -45. So we have now evaluated that bit. Part C, we have 2/3 raised to the power of 4. Now, from our previous experience, you can be able to recall that whenever we have division, then raised to a power, then we extend our loss for division. And this will tell you that we need to filter in the -4, which is going to affect both the numerator and the denominator. And this will give us 2 raised to the power of -4 all over 3 raised to the power of -4. That is the first step. The second step, we now need to rewrite this as positive indices. And that means we take their reciprocal. And when we take the reciprocal for this case, they are going to cross sides. 2 will go to the denominator with its power becoming positive. 3 will come to the numerator with its power becoming positive. So this will be 3 raised to the power of 4 over 2 raised to the power of 4. Now 3 raised to the power of 4, previously we had seen that will give you 81, while 2 raised to the power of 4 will give you 16. So we have 81 in the numerator and 16 in the denominator. Example 4, we are told express each of the following. As positive indices only. Number 1, we have a raised to -3 multiplied by 5 raised to -1 over y raised to -3. And B, we have 4 raised to -1 x raised to 2 y raised to -5, the whole of it divided by 4m raised to the power of -1 n raised to the power of -4. So again, this one requires us to both apply the knowledge on extension of the rules and also changing the powers from negative to positive. For the first case, we are going to look for the reciprocal of all these numbers because all their powers are negative. And as you shall be looking for the reciprocal of those particular numbers, their powers will automatically change from negative to positive. Like in this case, reciprocal of a is 1 over a, reciprocal of 5 is 1 over 5, reciprocal of 1 over y will be y. So this will be y raised to the positive power of 3 all over a raised to 3, 5 raised to the power of 1. Number B, we have 4 raised to the power of 1. So when we find its reciprocal, that will be 4 raised to the power of positive 1 multiplied by x squared will remain x squared because it's a positive index. Y raised to negative 5 will be 1 over y raised to positive 5. Then this 4 in the denominator will remain, so we still have 4. M raised to negative 1 over m raised to negative 1, m will go to the numerator to become m raised to 1, and again n will go to the numerator to become n raised to positive 4. So when we now simplify this, we shall have x squared mn raised to the power of 4 divided by 4 will give you 16 y raised to the power of 5. So that is how it's done. Example 5. The mass of a small insect, is 2 raised to 9 kilogram. How many grams? Is this rounded off to 2 decimal places? Now we have an insect which is measuring 2 raised to 9 kg, negative 9 kg. We are supposed to identify or find out how many grams that particular insect weighs, being or given that our number or our answer should be rounded off nearest to 2 decimal places. So solution, we have 2 raised to negative 9 kg, which is a negative index. Changing this to a positive index requires us to find the reciprocal of 2 for the power to be positive or to become positive. So this will be 1 over 2 raised to a positive 9. When we evaluate 2 raised to 9, you will get 512, which will give us 1 over 512. 1 divided by 512 is 0.0019 53125 kilograms. We convert this to grams by multiplying by 1000, since 1000 grams makes up 1 kg. And when you multiply that by 1000, you will get 1.953125 grams. We are required to round it off correct to 2 decimal places, and therefore this will be approximated to 1.95 grams. So that particular insect weighs 1.95 grams. I want us to now consider the final example to round up on negative indices, where we are told, example 6, find the value of x in these equations. Number 1, we are told that 2 raised to x is equals to 1 over 16. Number 2, 5 raised to x is equals to 1 over 625. So whenever we have these two particular cases, we first need to rewrite this as a factor of 2. So this will give us 2x is equals to 1 over 16 as a factor of 2 is 2 raised to 4. Then we rewrite this as a negative index so that we take it to the numerator or we find its reciprocal. This will be 2 raised to negative 4. Now whenever the bases are the same, then we can be able to equate the powers, and this will tell us that the value of x is negative 4. For this second case, the same is going to happen. We have 5 raised to x being equal to 1 all over. Now because this is 5, we need to find the factors of 5 that will give us 625, and that is 4. So when you take 5 raised to 4, you will get 625. So this will be 5 raised to x is equals to, when you find the reciprocal of that, it will be 5 raised to negative 4. And because the factors are the same, then we are going to equate the powers. Then this will tell us that x will be equal to negative 4. This brings us to the end of our discussion on the two subtopics, that is on the extension of the loss and on the negative index. Next time when we meet, we shall discuss on scientific notation. Thank you.